Good afternoon, students. In the previous class we learnt basic topics of thermodynamics. See, now we can see the next topic, pressure volume work. Our next topic is pressure volume work. So listen, in thermodynamics we are going to calculate the term work. In thermodynamics we are calculating the work involved in expansion or compression process. See, in thermodynamics, we are calculating the work involved in expansion or compression process. This process name we are telling, this process is known as pressure volume work or expansion work. Pressure volume work or expansion work. So listen, your topic is pressure volume work. In thermodynamics, in this lesson, we are calculating the term work involved in expansion or compression process. So this process name we are telling pressure volume work or expansion work. Understand? So listen, here your topic is, this is one of the important 5-mark question. Work involved in expansion or compression process. Work involved in expansion or compression process. So listen, this is one of the important 5-mark question. Listen, in most of the thermodynamics, we are calculating the work. In most of the thermodynamics, we are calculating the work involved in expansion or compression process. Expansion or compression process. For this process, we need one essential condition. For learning this process, we need one essential condition, main condition. The condition is, there should be a difference between external pressure and internal pressure. See, for learning this process, we need one essential condition. The condition is, there should be a difference between external pressure and internal pressure. There should be a difference between external pressure and internal pressure. Understand? See, for understanding this process, just consider a cylinder. For understanding this process, let us consider a cylinder. The cylinder contains n moles of ideal gas. The cylinder contains n moles of ideal gas. This one fitted with the piston. This one fitted with the piston of cross-sectional area A. So listen, for understanding this process, just consider a cylinder. Consider a cylinder. This one contains n moles of ideal gas fitted with a piston of cross-sectional area A. Now listen. Inside the cylinder, pressure and volume present. Pressure inside the cylinder is Pi and volume inside the cylinder is Vi. Pressure inside the cylinder is Pi and volume inside the cylinder is Vi. Just we are going to apply the external pressure. This external pressure is greater than internal pressure. Suppose this external pressure is greater than internal pressure. This external pressure is greater than internal pressure. This piston move inward. Till the internal pressure becomes equal to external pressure. So listen, this external pressure is greater than internal pressure. This piston move inward till the internal pressure becomes equal to external pressure. Understand this? So listen the process. Let us consider a cylinder contains n moles of ideal gas fitted with a piston of cross-sectional area A. Inside the cylinder, pressure Pi and volume Vi. If the external pressure is greater than internal pressure, piston move inward till the internal pressure becomes equal to external pressure. Now we are considering the final volume Vf. Understand this? the work is done on the system, we can use the formula. We can use the work formula W is equal to minus F into delta X. W is equal to minus F into delta X. You know W means work. F means force. And delta X is distance moved by piston. Delta X is distance moved by piston. See, if the work is done on the system means we are using the formula W is equal to minus F into delta X. Understand? Now listen. Here force formula. Force F is equal to external pressure into cross-sectional area. Force F is equal to external pressure into cross-sectional area. Just consider this is equation 1. Substitute this force value in equation 1. See, listen. Force value. Force F is equal to external pressure into cross-sectional area. So, substitute F value in equation 1. Substitute this F value in equation 1. If you are substituting, tell the answer. W is equal to F value P external into A into delta X. Understand? Now listen. This A into delta X means. See, this A into delta X means that is change in volume. A into delta X means change in volume is equal to V final minus V initial. A into delta X means change in volume, V final minus V initial. Just to substitute this value. So substitute this value. Just to consider this is equation 2. Substitute this value in equation 2. If you are substituting, tell the answer. W is equal to minus P external into A into delta X is V final minus V initial. Understand this? See, listen. V final minus V initial. See, already you know delta V means V initial minus V final. Delta V means V initial minus V final. But here V final minus V initial. So V final minus V initial means that is minus delta V. So minus delta V is equal to V final minus V initial. Just to substitute this value. So tell the equation. W is equal to minus P external into minus delta V. Understand? Minus into minus plus. So your answer is W is equal to P external into delta V. So listen, you got the answer positive. So if the work is done on the system means, if the work is done on the system, W becomes positive. W becomes positive. Understand this? Now listen, here this pressure is not constant. This pressure is not constant and changes during this process. Suppose if you are doing any changes in this process, if you are doing any changes in this process, this pressure value is not constant. This pressure value is not constant and this volume you got the decreased volume dV. You will get the decreased volume dV. So listen, if you are doing any changes in the process, pressure is not constant and volume you will get the decreased volume dV. You will get the decreased volume dV. Understand this? Now listen, next condition. If the work done on the gas, if the work done on the gas, we are using the work formula. W reversible is equal to minus integral V initial to V final P external into dV. See, listen. If the work done on the gas, we are using the work formula. W reversible is equal to minus integral V initial to V final P external into dV. Understand this? In a compression process, external pressure is always greater than the pressure of the system. See, in a compression process, external pressure is always greater than the pressure of the system. So here we are using, in this process, we are using the formula external pressure is equal to internal pressure plus dP. Internal pressure plus dP. See, if your process is compression process, we are using the formula P external is equal to P internal plus dP. Understand? Suppose if your process is expansion process. If your process is expansion process, external pressure is less than pressure of the system. External pressure is less than pressure of the system. So here we are using the formula P external is equal to P internal minus dP. P external is equal to P internal minus dP. Understand? So we are using two conditions. Compression process means P external is equal to P internal plus dP. Expansion process means P external is equal to P internal minus dP. Understand? Just to plot the values, pressure and volume. Here volume changes from initial to final states. Here this pressure is not constant. And changes takes place in, here this process takes place in very small steps. So listen, just to plot the value pressure and volume. Volume changes from initial to final states. This pressure is not constant and this process takes place in small steps. And together, see, we got two formula, compression and expansion process. This two formula together we are writing. Just listen. P external is equal to P internal plus or minus dP. P external is equal to P internal plus or minus dP. This is work done on the gas. So you got the formula P external is equal to P internal plus or minus dP. Understand? See, for a compression process, work is related to internal pressure of the system under reversible condition. For a compression process, work is related to internal pressure of the system under reversible condition. So we are writing the formula. Just listen, we can write the work formula. W reversible is equal to work under reversible condition. So W reversible is equal to minus integral P internal into dV. So tell the formula W reversible is equal to minus integral V initial to V final P internal into dV. Now listen, already you know the formula ideal gas. Ideal gas equation is PV is equal to N into RT. Ideal gas equation PV is equal to N into RT. Here this pressure, you just consider this pressure is internal pressure. So we can write P internal into V is equal to N into RT. From here calculate the P internal. For P internal is equal to, just to take this V outside, that's it, right side. So P internal is equal to nRT divided by V. Substitute this P internal value in this equation. So tell the value, if you are substituting, you will get the answer. W reversible is equal to minus integral V initial to V final P internal value nRT divided by V into dV. Understand? Now listen. Here these three values are constant. N, R, T. N is the number of moles. R gas constant. T temperature. Take these values outside. So tell the formula. W reversible is equal to minus nRT integral V initial to V final dV divided by V. Understand this? See, integral dV by V. You know the formula. Integral 1 by x into dx means that is ln x. So here 1 by x into dx means ln x, but here 1 by v into dv. So tell the formula. You will get the formula W reversible is equal to minus nRT. Just integrate this. If you are integrating, you will get the answer ln v. Ln v of v initial to v final. V initial to v final. If you are taking this inside, you will get the answer W reversible is equal to minus nRT of ln Vf minus ln Vi. Understand? See, this formula is similar to ln A minus ln B. Ln A minus ln B is equal to ln A divided by B. This is A, this is B. So tell the answer. W reversible is equal to minus nRT of ln Vf divided by Vi. Vf divided by Vi. Understand? Now listen. One ln is equal to 2.303 log. 1 ln is equal to 2.303 log. If you are substituting, tell the answer. W reversible is equal to minus nRT into 1 ln value 2.303 log Vf divided by Vi. Just arrange this equation neatly. So you will get the answer. W reversible is equal to minus 2.303 minus 2.303 nRT log Vf divided by Vi. Understand? If the work done on the gas means you got the answer. Work formula W reversible is equal to minus 2.303 nRT log Vf by Vi. Understand this? See here, you know the formula log Vf by Vi. Here suppose Vf value greater than Vi. This Vf value greater than Vi means W reversible value. This W reversible value you will get negative. This Vf value greater than Vi means you will get the answer. W reversible value you will get negative. Suppose this Vf value less than Vi means. This Vf value less than Vi means you will get the W reversible value. W reversible is equal to positive. This value greater, Vf greater means W reversible negative. Vf value lesser means W reversible positive. Understand this? See, today we learn one important 5-mark question. Work involved in expansion or compression process. Work involved in expansion or compression process. Just let's recall once again the important points. So listen, first we learn the first condition. Work done on the system. If the work done on the system means we are using the work formula W is equal to minus F into delta X. W is equal to minus F into delta X. Here first substitute the F value. If you are substituting F value, you got that. You know the formula F is equal to F is equal to A into delta V. F is equal to A into delta V. Just substitute this values. If you are substituting, you got the answer. W is equal to P external into dV. P external into dV. So W becomes positive. So your condition is, if the work done on the system, W becomes positive. Then second condition, work done on the gas. Work done on the gas. Work done on the gas means we are using the work formula. W reversible is equal to minus integral V initial to V final P internal into dV. Here we are applying two processes. One is compression process and another one is expansion process. Compression process means P external is equal to P internal plus dP. At the same way, expansion process means P external is equal to P internal minus dP. Compression process means P external is equal to P internal plus dP. Expansion process means P external is equal to P internal minus dP. Here we are considering the ideal gas. Ideal gas formula you know, PV is equal to N into RT. If you are substituting this values, you will get the answer. W reversible is equal to minus 2.303 nRT log Vf by Vi. W value becomes negative. See, work done on the system means positive. If the work done on the gas means you got the answer, W value becomes negative. Understand? Here we learned one condition. Suppose this Vf value greater than Vi means W negative. Suppose this Vf value less than Vi means W value becomes positive. Understand this? See, this is one of the important 5-mark question. You must learn this question thoroughly. Understand this? See, now take page number 192. Pressure volume work. In elementary thermodynamics, the only type of work generally considered is the work done in expansion or compression of a gas. This process only we are telling pressure volume work, PV work or expansion work. And take page number 193. Here this is only important 5-mark question. Work involved in expansion or compression process. Work involved in expansion or compression process. Once you read this topic, listen. In most thermodynamic calculations, we are dealing with the evaluation of work involved in the expansion or compression of gases. And for this process, we need one condition. The condition is difference between external and internal pressure. Then the process, for understanding the process pressure volume work, let us consider a cylinder. Let us consider a cylinder contains n moles of ideal gas. Contains n moles of an ideal gas fitted with a frictional piston. Fitted with a frictional piston of cross-sectional area A. Cross-sectional area A. So total volume inside Vi, total pressure inside Pi. Then suppose this external pressure is greater than internal pressure. The piston move inward till the external pressure becomes equal to. Till the external pressure becomes equal to internal pressure. And now we are telling the final volume Vf. Final volume Vf. Now the first condition, listen. If the work is done on the system, if the work is done on the system, it can be calculated as, work is done on the system means we are using the work formula. W is equal to minus F into delta X. W is equal to minus F into delta X. Delta X or dx. So dx is the distance moved by piston. F is the force acting on the gas. Force acting on the gas. Then here force formula you know. Force F is equal to P external into A. Just to substitute this F value in this equation. If you are substituting, you got the answer. W is equal to minus P external into A into delta X. A into delta X means that is change in volume Vf minus Vi. Substitute this value in this equation. Then here Vf minus Vi means, that is, see, usually Vi minus Vf means delta V. At the same time, Vf minus Vi means minus delta V. Vf minus Vi means minus delta V. Here Vf minus Vi. So substitute this value. So your answer W is equal to minus P external into minus delta V. Minus into minus plus. So P external into delta V. Understand? You got the answer positive. So work is done on the system. It is a positive quantity. Then see the next point. If the pressure is not constant but changes during the process, it is always infinitesimally greater than the pressure of the gas. This pressure is always greater than the pressure of the gas. So you got the decreased volume dV. Then see, this is the first condition. Then second condition, work done on the gas. If the work done on the gas means, page number 194, formula W reversible is equal to minus integral V initial to V final P external into dV. Here we are using two process. Compression process means external pressure is greater than the pressure of the system. So P external is equal to P internal plus dP. Suppose if it is expansion process, this external pressure is less than the pressure of the system. So P external is equal to P internal minus dP. Just plot the values, pressure and volume. Volume from Vi to Vf. You got the shaded area. See, listen, here this pressure is not constant and changes takes place in small steps. And this compression takes place from V initial to V final. V initial to V final. And the shaded area represents work done on the gas. So work done on the gas is represented by the shaded area. The next, generally we are writing these two processes together. We are writing P external is equal to P internal plus or minus dP. This process name we are telling reversible process. Reversible process. The next, suppose if you are taking compression process, for a compression process, work can be related to internal pressure of the system. Work can be related to internal pressure of the system under reversible condition. So we are using the formula W reversible is equal to minus integral V initial to V final P internal into dV. Just to consider the ideal gas equation, PV is equal to nRT. Pressure we are taking P internal. So P internal into V is equal to nRT. Calculate the P internal value. So take this V out right side. P internal is equal to nRT by V. Substitute this value in this equation. If you are substituting, tell the answer. W reversible is equal to minus integral V initial to V final P internal value nRT by V into dV. Take this constant values outside. So you got the answer minus nRT into dV by V. This formula is similar to integral 1 by x into dx equal to ln x. If you are substituting, you got the answer this one. Ln V minus nRT into ln V, Vi to Vf. If you are taking this, ln Vf minus ln Vi. Ln Vf minus ln Vi. This formula is similar to ln A minus ln B. Ln A minus ln B means ln A by B. Ln A by B. If you are substituting, you got this answer minus nRT into ln Vf divided by Vi. Here you know 1 ln value. 1 ln is equal to, see, 1 ln is equal to 2.303 log. 1 ln is equal to 2.303 log. Substitute this value, you got the answer W reversible is equal to minus 2.303 nRT log Vf divided by Vi. Understand? Now suppose here this Vf value is greater than Vi. This work done by the process is negative. This value greater means you will get the answer negative. Then suppose if this Vf value less than Vi means work done on the process is positive. Understand? So your question, if your question work involved in expansion or compression process means page number 193 from this to in most thermodynamic calculations from here to till page number 194 right side work done on the process is positive. See, this is one of the important 5-mark question. You must learn this topic thoroughly. Your tomorrow's homework topic, this one only. See, learn this topic thoroughly. Now listen, we can see the next topic. This is on simple condition only. Just read this. Sometimes this is 2-mark question. Summary of sign conventions. Summary of sign conventions. Already we learned the topic heat and work. Heat and work. See, heat and work. We are just heat condition and work condition. Sign of heat and sign of work. Sign of heat and sign of work. If heat is absorbed by the system, suppose heat is absorbed by the system, sign of heat is plus Q, positive. Suppose the heat evolved by the system, sign becomes negative. If the heat absorbed by the system, sign positive. The heat evolved by the system, sign becomes negative. Same way, work. If the work is done by the system, negative. If the work is done on the system, positive. See, heat absorbed means positive. Heat evolved means negative. Work done by the system means negative. Work done on the system means positive. See, this is sign convention of heat and work. Sign convention of heat and work. This is sometimes this is 2-mark question. Just to learn this topic also. See, now take page number 225. Page number 225. Question number 49. Question number 49. Calculate the work involved in expansion or compression process. Calculate the work involved in expansion and compression process. That's today's topic only. Page number 193. Page number 193. From here to in most thermodynamic calculations from here to till page number 194. Work done on the process is positive. Understand?